big topic here with functions. So functions is so the notation with functions. If I have this is function notation. It's pronounced f of x. So if I could have f of x equals some function like 2x plus 3, compared to when we had equations like y equals 2x plus 3, where it's just an equation. Function has that same kind of concept to it, where if we plug in an x value, we get back a y value. But now we're going to really dig into what a function is. So in a function, relation, let's just talk about relation first. Relation is a set of ordered pairs. And looking at a relation and digging a little bit deeper into a relation, we could find the domain and range of a function, which we'll talk more about. So the domain is all of the x values, and the range is all of the y values. So the domain is all the x values, like where does this function exist on the x-axis, like where would this be? And the range, where does this function exist on the y-axis? So what y values do we get in this function? So number one, find the domain and range of this relation. So the relation, set of ordered pairs. So we want to find the domain and range. The domain is all of the x values. So the domain is going to be 2, 1, -2, and 3. Which is all the x values. And then the range is going to be all of the y values. All of the y values. So we have 0, 3, 2, and -3. So that is the range of this whole relation. Now, determining whether a relation is a function. So when we have a function, let me go back up to the top here. I like to think about a function being like a machine. So what happens with a function is we take an x value, we plug it into this machine, and out pops a y value, creating an ordered pair. So what has to happen in order for this to be a function is the x value has to correlate with exactly one y value. When I plug in this x value into this function, I am not getting two different y values. I'm only getting a single y value. There is only one thing that happens when I put this x value into this machine, and out comes a y value. That's the only thing that could happen. So in order for it to be a function, the x value has to go to exactly one y value. So in order for it to be a function, x value has to have exactly one y value. So let's take a look at these examples here. Letter A, -3, -2, -1, -5, 8, 9, -9, 2. So we want to check to see, does each x value have exactly one y value? And there's a couple different ways that you could identify this, but I wanted to show you what's called a mapping diagram. So if we take all the values in the domain and all the values in the range, so the domain is -3, so remember, domain is the x values, range are the y values. So the domain -3, -1, 8, and -9. Then write down all the y values in the range. So -2, -5, 9, and 2. And if we have repeats, don't repeat anything. So first one, -3, -2. So I'm going to map that x value to that y value. -1, -5. So -1 maps to -5. Next order pair, 8, 9. So that x value maps to that y value of 9. And then this x value of -9 maps to that y value of 2. So we have the domain and range. I'm mapping out these ordered pairs. And as we could observe here, each x value is only going to exactly one y value. They're not going to multiple. Like this -3 is not going to -2 and -5. Or this -1 is not going to -5 and 9 or -2. All x values are going to exactly one y value. So in this case, we'd say, yes, this is a function because these ordered pairs are only, these x values in these ordered pairs are only going to one y value. So that is a function. So if I take the x value, I'm getting one y value. Let's take a look at letter B. So the domain is all the x values. So the first order pair is 4, -3. Next order pair is 4, 5. I'm not going to rewrite 4. My last order pair is 4, -7. I'm not going to rewrite 4 again. The range is -3, 5, and -7. So let's map. The first order pair is 4, -3. Next order pair, 4, 5. Next order pair, 4, -7. So what are you noticing here? This x value of 4 is going to 3 different y values. That is not a function. That's a no. We cannot have an x value going to more than one y value. So 4 is going to -3, 4 is going to 5, 4 is going to -7. So it's going to more than one y value, so therefore it's a no. Now, what if this happens? I want to look at this example. So I'm just going to make this up here. Let's say I have the domain of like 1, 2, 3, 4, 5. And all of these domain values are going to one y value of, let's just say, 6. So if I map these, we have ordered pairs 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So in this example, each x value is going to exactly one y value. They're all going to the same y value, but that's okay. That's a yes. That is a function. Each x value can go to the exact same y value as long as the x value is only going to one y value. Like if we had this same scenario and then I just threw in like one more ordered pair, like 1, 3. So we have the ordered pair 1, 3, 1, 6. Then it would not be a function because now the x value of 1 is going to more than one y value. So in this case, though, where all these x values are going to one y value, that's fine. That is a function. Let's take a look at a graph and identify if it's a function. So in order for it to be a function on a graph, same thing has to happen. Each x value can only go to one y value. So what we don't want to have happen is 2 points on the same x value. So if we look at this first x value here, here's order pair, this first point. I don't have any other points along this x value of -2. So at the x value of -2, it is corresponding with the y value of 3. So that's good. Next x value, this x value of -1 has one output of 3. So that order pair would be -1, 3. I do not have any points on the x value of -1. So that's okay. This next one at y is equal to 1. I'm sorry, not y equals to 1. X equal to 1. We have an output of 3. And we have an output of -2. So if I were to write this down, this ordered pair would be 1, 3, right here. And then this ordered pair would be 1, -2. So what are you noticing? This domain value of 1 is going to 2 different y values. This x value of 1 is going to more than one y value, so therefore this would be no, because of right here. This point right here. Those 2 points are in the same x value of 1, so the whole thing, this whole graph, is not a function. So not a function. Even though these were okay, we want the whole graph to qualify as a function. So even though those 2 points, this would still be a no because of that. Let's take a look at letter B. So we want to go through each point. So I have this one. I do not have any other x values y values corresponding to the x value -2, just that. So that's okay. Let's check the next one. Next one, -1, -3, the x value of -1, y value of -3, function, or not function, but that's okay. Next one, the x value of 0, we have an output of 3, so that's okay. I don't have any other points on my x equal to 0 line here. X equal to 1, I have an output of 2, nothing else. X value of 2, I have an output of -1, nothing else. So I have everything being good to go there, so that one's a yes. And then next, with functions, using a vertical line to determine whether each graph is a function. So what did you notice here as I was going through these examples? We were looking at these x values, wherever those points were. And what I was just trying to introduce was this concept of, well, if I have a line at the x value of -2, I don't have any more points on that line. I just have this single point, nothing else. What about right here? I had 2 points on that line. So what I was doing a little bit was creating vertical lines. So there is what's called a vertical line test, meaning if you look at this graph, so we have this line here, and I'm going to use vertical lines. So I'm going to draw in vertical lines. And if I don't hit a vertical line in more than one spot, then it is a function. So if I draw vertical lines, you see how when I draw those vertical lines, I'm not hitting this line in more than one spot on a single line. Let me erase this. So if I draw a single vertical line, see how I hit the line right here? I'm not hitting this vertical line anywhere else. Right there, right there. I'm not hitting in 2 spots. So that's a function. So each x value is corresponding to one single y value. So that's good. So that's yes. Next one, this horizontal line. There's a horizontal line right there. So if I drew in vertical lines, I'm hitting the line right there, line right there, line right there, and so on. So I'm not hitting that line in more than one spot with a vertical line. So that's a yes, it's a function. And letter C, the vertical line test. So here is the graph here, that curved parabola there. So if I drew vertical lines, see this? Look at that. I'm hitting in two spots. A single vertical line is hitting this graph in two spots. So that means it's not a function, because the x value, if I were to drill into this a little bit more, the x value of, let's say, like -2 right here, it's corresponding to that y value and that y value. The x value of -1, that y value and that y value. So these x values are going to more than one y value. So that's a no. And then letter D, same thing. Here's a circle. Drawing vertical lines, it's hitting everywhere. It's just not a function anywhere there. So that's a no, because I'm hitting this x value is going to this y value, this y value. This x value is going to this y value and this y value. It's hitting in more than one spot, multiple places. So that's the vertical line test, drawing in vertical lines. And last one for this video, we have a graph regarding the sunrise in towns for a city. Approximate the sunrise on October 1st. So October 1st, let's go into this graph a little bit more. October 1st is, so the way we read this graph, this is the beginning of October, and then this is the end of October going into November. So October 1st would be the beginning, right about there. And it's not quite 6 a.m. Like if you look, 6 a.m. is this white line going across, so it's not quite there. So it's a little bit below 6 a.m., so let's just call that like 5:45. I think it would be okay there. When is the sunrise? 7 a.m. So here's 7 a.m. right here, across here. And it looks like February 1st is sunrise of 7 a.m. And then if you look at the far end here, it almost looks like December we'd consider 7 a.m., but it doesn't look like it's quite there at 7 a.m., but it's pretty close, but not quite. So let's just call February 1st, 7 a.m., beginning of February. Is this graph a function? So is this graph a function? We have this graph, it kind of goes, it stays up, goes down. If I were to draw vertical lines in, I do not hit that line in more than one spot anywhere, so then that would be yes, that is a function. So just an introduction to identifying functions or not.